You know, it's something we do dozens, maybe hundreds of times a day. We click a link, type in a web address, and bam, a whole new world just appears on our screen. It feels instantaneous, almost like magic. But what's really happening behind the curtain is this lightning-fast, incredibly complex journey. So in this explainer, we're going to follow a single web request, from the moment you click all the way to the final page you see.
So have you ever really stopped to think about what's happening in those few milliseconds after you click? That single action kicks off a wild journey that can literally span the globe in the blink of an eye. We're going to break this whole thing down, step by step, and turn those invisible milliseconds into a story that actually makes sense. Okay, so our journey starts with something we all know and use every single day, the web browser. It's our window to the web, our trusted guide, and it's the starting point for absolutely everything that's about to happen. Believe it or not, the browser you're using right now was basically forged in fire. For decades, these companies battled it out in what we call the browser wars. This intense competition, from the early days of Netscape and Internet Explorer to the rise of Google Chrome, forced incredible innovation and pushed the technology forward, making our browsers faster and more powerful than ever.
So yeah, your browser is way more than just a simple window. It's a seriously complex piece of machinery. You've got the user interface, that's all the buttons and tabs you see, but under the hood, there's a browser engine managing everything. A rendering engine that actually draws the web page, and a JavaScript interpreter to handle all the interactive bits. It's the conductor for this entire orchestra.
All right, so we've clicked the link. Now what? Well, the browser's first job is to play detective. It has to figure out where in the world it needs to go to get the web page. It needs an address.
And the way it finds that address is by using something called the DNS, or Domain Name System. Honestly, the best way to think about it is that it's literally the internet's phone book. We remember names, right? Like Google.com. But computers, they talk in numbers, IP addresses. DNS is the incredible global system that translates the name we can remember into the number the computer needs.
And this whole lookup thing? It's like a super fast game of telephone. Your browser asks a local server, which asks a root server, which points it to the right .com server, which then points to the final server that has the actual IP address. This chain of requests bounces around the world in milliseconds, all to get that one crucial address back to your browser so it knows where to go.
Okay, address in hand. Now our browser knows exactly where to go. It's time to actually reach out and start talking to the web server. You know, every conversation needs a common language, right? Well, on the web, that language is called HTTP. It's basically the official rule book, the grammar, that lets your browser, which we call the client, make a request and lets the web server provide a response in a way that both of them can perfectly understand.
And just like any language, HTTP has had to evolve. The first version, 1.0, was, well, it was kind of slow and clunky. It would open a brand new connection for every single piece of a website. The text, then a new one for an image, another for another image. It was really inefficient. But HTTP/1.1 was a game changer. It introduced persistent connections, which meant the browser could just keep the line open and download a bunch of files at once. This made the web feel so much faster.
But here's the thing. This isn't just your browser asking for stuff. When that HTTP request goes out, the server on the other end is actively listening and gathering information from that request. For example, the server sees your IP address. It knows what website you actually asked for, and it can even see where you came from, like if you clicked a link on Google. This isn't for spying, it's all crucial information that helps the server figure out exactly what content to send back to you.
Okay, mission accomplished on the server's end. It's processed our request, gathered up all the necessary files, and fired them back across the internet. Now, for the grand finale, your browser has to take all that raw data and turn it into the web page you actually see.
And it all starts with the absolute bedrock of every single web page out there, HTML. It was invented way back in 1989 by Tim Berners-Lee, and it provides the fundamental structure. It's the blueprint, the skeleton that gives the page its basic shape, telling the browser, this is a heading, that's a paragraph, and here's an image.
So what does that skeleton look like all by itself? Well, this. As you can see, it's just pure structure. All the information is there, all the content is in order, but let's be honest, it's not exactly pretty. It's functional, but it's not what we've come to expect.
This is where the magic really happens. To go from that bare-bones list to a modern website, we need CSS. If HTML is the skeleton, then CSS is all the cool stuff, the clothes, the style, the personality. It's the code that tells the browser what colors to use, what fonts to load, and how to lay everything out on the screen.
And boom, check this out. This is the exact same HTML structure as before, but now with CSS applied. The difference is just, well, it's night and day, isn't it? This transformation is what makes the modern web look and feel so polished and easy to use. It's an incredible partnership.
So there you have it, the entire journey from a single click to a fully loaded page. But, the story doesn't end here. The web is a living thing. It's always evolving. There's a whole global community of people constantly working to make it faster, smarter, and more accessible for everyone. Take speed, for instance. A newer version of that web language, HTTP/2, is way more efficient. And even a few years ago, back in late 2017, you can see that over 18% of the world's top websites had already jumped on board, all in a relentless quest to shave off precious milliseconds of loading time.
And it's not just about speed. We're making the web smarter, too. There's this idea called linked data, which is basically about teaching computers to understand what web content is about, not just what it says. It's about turning the web from a giant library for humans into an interconnected database for machines.
And maybe most importantly, we're working to make the web more inclusive. The Web Accessibility Initiative lays out these 4 core principles. Can people perceive the content? Can they operate the interface? Is it understandable? And is it robust enough to work on all sorts of devices? It's all about ensuring the web is built for people of all abilities, period. So when you think about it, that whole journey, from one tiny click to this massive global network of information, it's just incredible. And it leaves us with a really big question. As the web continues to connect billions of us, the challenge for all of us is, how do we keep pushing to build a web that is truly faster, smarter, and more inclusive for every single person on the planet?